Hi, hello everyone. Welcome to SK Academy of Mathematics. Today let us learn how to solve the problem on basis and dimension where we need to find where they have given the set of vectors. Considering this set of vectors, we are going to represent with respect to matrix and we are going to reduce by using row elementary operation form and we are going to find the linearly independent condition and then we are going to conclude the given set of vectors with respect to basis and dimension. How we are going to verify? Now let us see. First, represent the given set of vectors with respect to matrix form, that is given. Let us represent the matrix capital letter A, that is first set of vectors with respect to first column, that is 2, minus 1, minus 3, minus 1. Next we have second vectors 1, 2, 3, minus 1. Next we have 1, 0, 1, 1. The last vector we have 0, 1, 1, minus 1. By using elementary row operation, we are going to reduce this matrix. First, what we are going to do, just interchange the row. That is, R2 changes to R1, which will be equivalent to 1, 2, 3, minus 1, 2, minus 1, minus 3, minus 1, 1, 0, 1, 1, 0, 1, 1, minus 1. What is my aim? Below the diagonal elements, every element I need to make it as 0. That is using upper triangular matrix. See, this is the diagonal elements 1, minus 1, 1, minus 1. Below this 2, 1, 0, 0, 1, 1. I need to make it as 0. So what I am going to do using elementary row operation, R2 dash changes to R2 minus 2 times of R1. Okay, which will be equivalent to, okay, let us write here itself, which will be equivalent to, first row remains same, that is 1, 2, 3, minus 1, 2, okay, sorry, now we need to simplify here. What is R2? We have 2, minus 1, minus 3, minus 1, minus, 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 2, 2, 2, 2. What is R1? We have 1, 2, 3, minus 1. Now, just use the calculator. We can simplify. 2 minus 2, you get 0. Always use the calculator for the exact and perfect solution. Minus 1, minus 2 into 2, which is equal to minus 5. Which is equal to, next, minus 3, minus 2 into 3. Which we have minus 9. Last, minus 1, minus 2 into minus 1. We have 1, which will be equal to 0, minus 5, minus 9, 1. Done with the second row. Now let us simplify the third row. That is R3 dash changes to R3 minus R1. What is R3? 1, 0, 1, 1, minus, 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 minus. What is R1? 1, 2, 3, minus 1. Which will 1 minus 1, 0, 0 minus 2, minus 2, 1 minus 3, minus 2, minus into minus plus 1 plus 1, 2. Where 0, minus 2, minus 2, 2. Since the last row, assume since the last row is same, what I see, because now not same, since the last row first element is 0, so I am going to consider it as constant. 0, 1, 1, minus 1. Now see, below which element I need to make it as 0? Now what are the diagonal element? 1, minus 5, minus 2, minus 1. Below this I need to make it as 0, 0, 0. Below the element I have made 0. Now 5 below this, minus 2 and minus 1, next 1. So what I am going to do, just I am going to interchange. That is, because fourth row leading element is 1. Or else let us divide this only. That is, R3 dash changes to minus R3 divided by 2. Which will be equivalent to Let us erase this part, which will be equivalent to 1, 2, 3 minus 1, 0, minus 5, minus 9, 1, 0, minus 2 by, see, minus of minus 2 by 2, minus into minus, plus 1, 1, minus 1, 0, 0, 0, minus 1. If you look into this matrix, third row and fourth row is same. So what I am going to consider, considering one row as constant, that is third row as constant, I am going to reduce this fourth row. How? R4 dash changes to R4 minus R3, which will be equivalent to 1, 2, 3 minus 1, 0, minus 5, minus 9, 1, next 0, 1, 1, minus 1, 0, 0 minus 0, 0, 1 minus 1, 1, sorry, 1 minus 1, 0, 1 minus 1, 0, minus 1, minus of minus 1, plus 1, plus 1 minus 1, 0. Always we know that leading element should be 1. So what I am going to do, just interchange. R3 interchanges to R2, which will be equivalent to 1, 2, 3 minus 1, 0, 1, 1 minus 1, 0, minus 5, minus 9, minus 1. Okay, sorry, plus 1. Yes, plus 1. Next we have 0, 0, 0, 0. Yes, yes. After this, see, now what is our diagonal elements? 1, 1, minus 9, 0. Below this element, that is minus 5, I need to make it as 0. So what I am going to do, R3 dash changes to R3. Since I have negative, I am going to consider positive 5 times of R2. Then what we are going to get? Which will be equivalent to 1, 2, 3 minus 1, represent the matrix. Next 0, 1, 1 minus 1. Now let us reduce this part. What is R3 we have? 0, minus 5, minus 9, 1, plus, 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 5, 5, 5, 5. What is R2? 0, 1, 1, minus 1. Got it? Yes. Everything multiplied by 0, 0. Plus 5, minus 5 get cancelled, 0. Next we have minus 9 plus 5 into 1, 5. You get minus 4. Last we have 1 plus 5 into minus 1. You get minus 4. Then what you are going to get? 0, 0, minus 4, minus 4. Last row will be 0 as usual, 0, 0. Since this is the multiple of minus 4, the third row is multiple of minus 4. What I am going to do, just divide. R3 dash is divided by minus R3 divided by 4, which will be equivalent to 1, 2, 3 minus 1, 0, 1, 1 minus 1, 0, 0, 1, 1, 0, 0, 0, 0. Now this is the M. See, till here is the simplification. After this we can't reduce the matrix. Now after this, also see how many non-zero rows are there? We have 3 non-zero rows. 1, 2, 3. How many zero rows are there? 1 single row we have. Now how to conclude? The non-zero rows of this form a basis of what? Of the subspace S spanned by V of what? Spanned by V of the vectors and the dimension. What do you mean by dimension? Dimension of S is 3. Therefore, this is the conclusion. Therefore, the basis of the vector are, now vectors, to represent the basis we are going to consider the number of non-zero rows after reducing with respect to row echelon form. The number of non-zero rows we represent with respect to vector form. First row, that is 1 2 3 minus 1 comma 0 1 1 minus 1 comma 0 0 1 1. This is the basis. And what is the dimension? Dimension of A, that is the dimension of A, the represented matrix, is 3. What does dimension represent? The number of non-zeros. 1 2 3. Basis represent the number of elements present in the matrix with respect to non-zero elements. I hope you have understood this problem step by step. This is how we are going to represent the basis and dimension of the given set of vectors. I hope you have understood this problem step by step. For more videos, please do like, share and subscribe. See you in the next video. Thank you.